Hello students, we are now looking at objective number 14 in Algebra 1 called Slope and Intercepts. So let's look at problem number 1. Find the slope of the line that passes through each pair of points. So part A, we're given the points 3, 7 and negative 1, 4. Okay, so write down exactly what I write down. Now, I'm going to show you two different ways to approach this problem. First way is the way that I would prefer that you use because it will be helpful for any type of slope problem. And that is simply to use the slope formula. The slope formula look like this. Slope equals the second y-coordinate minus the first y-coordinate, all divided by the second x-coordinate minus the first x-coordinate. Okay, that is the slope formula. Now, once we have that, all we need to do is identify what our coordinates are. So the 3 is the first x-coordinate, the 7 is the first y-coordinate, negative 1 is the first x-coordinate, 4 is the second y-coordinate. Okay, so write that down. And then all we have to do is simply plug in these numbers into the slope formula. So slope equals 4 minus 7 divided by negative 1 minus 3. And then simplify that. Negative 3 divided by negative 4. And then that can be simplified even further to 3 over 4. Because the two negative signs cancel out. Okay, so that is the slope of the line passing through those 2 points, 3 over 4. Now let's verify that graphically. Let's verify that. I have my grid paper here, and then I'm going to draw a set of axes real quick. Now, over 3, up 7, bada bing. So this is 3, 7. And then negative 1, up 4. Negative 1, 4. Okay? And then look at that. There's a line that passes between these 2 points. The rise between the 2 points is 3, and the run between the 2 points is 4. So the slope is rise over run. 3 over 4, which matches exactly what we found algebraically. Okay? Now let's try the next problem. Negative 3, 2 and 6, 2. Let's find the slope of the line passing through those 2 points. Again, I'm going to identify what my x1, my y1, my x2, and my y2 are, and then I'm simply going to plug them into the formula. Slope equals 2 minus 2 divided by 6 minus a negative 3. 6 minus a negative 3. Okay, be very, very careful. You have to include that minus sign there. And this is going to end up being 2 minus 2 is 0. 6 minus a negative 3. The negative signs right next to each other cancel out, they become positive, so 6 plus 3, so 0 divided by 9. Now 0 divided by 9 is simply 0. Whenever you have the 0 on top of a fraction, it becomes 0. Okay, so the slope of this line is 0. And again, let's check that graphically. And I encourage you, whenever you're doing problems like this, to check your answer graphically. Do it this way first, if possible, and then check your answer graphically. Again, I encourage you to use the slope formula. I want you to, because for the end of course test, for example, you're not going to have access to graph paper. So negative 3 up 2, right there, and over 6 up 2, and voila, we can see that the line is horizontal, and all horizontal lines have 0 slope. Okay, the rise is 0, the run is whatever that is, slope is 0. let's move on to the next problem. Let me read this for you. In 2001, the average cost of tuition, room, and board at public four-year colleges was $8,022. In 2012, the average cost was $14,794. Find the yearly rate of change in the average cost of tuition, room, and board. Now, in order to do this problem, we have to identify it, first of all, as being a problem involving slope. And the reason we know that it has to do with slope is because of this right here, rate of change. Slope is the same thing as rate of change. Okay, so that means let's try to identify what our x1, y1, x2, and y2 are. Okay, well, we're looking for the rate of change in the cost of tuition over how many years it takes. Okay, so what we're looking at is change in tuition and room and board and all that over the change in time. Okay, how much time does it take for the tuition to change by that certain amount? So this means that we're going to take our y2 is the cost at the end of this time interval. Okay, so we're doing the slope formula again, y2 minus y1 over x2 minus x1. The y2 is where we end up, 14,794, minus where we started. This is y1, 8,022. And then we divide that by, now the final year is 2012. This is our x2. Okay, notice that the x2 and the y2 are paired, and they are on top of each other in the slope formula, minus where we started. This is our x1, 2001. Okay, so we can do that in a calculator real quick. $14,794 minus 8,022. Okay, so we just found this number, 6,772. So the tuition and room and board increases by $6,772 over a course of 11 years. Okay, and then we can simplify that further. We can find what the decimal approximation is. Okay, so that gives me a fraction. Now I'm going to go to menu, number, convert to decimal. About 616. Okay, so in the context of this problem, this means that the yearly rate of change is about $616 per year. Okay, that is the yearly rate of change. So each year, your tuition, room, and board is expected to go up by about $616. Okay, now let's look at problem number 3. From the equation 5x minus 2y equals 12, find the following. Find the slope, the y-intercept, and the x-intercept. Now, you're going to be writing this down with me. Okay, so write down that equation. Now, currently, this equation is written in standard form. Standard form. Okay, ax plus by equals c. Okay, a is 5, b is -2, c is 12. Now, standard form is nice because it allows you to find the y-intercept and the x-intercept very easily. Okay, and this is what we do. Let's first of all find what the y-intercept is. In order to find the y-intercept, you have to make x 0. Okay, when the line representing this equation crosses the x-axis, that means that, when it crosses the y-axis, that means that you have the y-intercept, and that means that x is 0 there. So all you have to do in order to find the y-intercept from an equation that looks like this is to simply put your finger over 5x. And then now you have an equation that just has y in it. Negative 2y equals 12. Now solve that equation for y by dividing both sides by negative 2. So y equals negative 6. Okay? And that is the y-intercept, negative 6. That wasn't too bad. Now, let's do the same exact thing to find the x-intercept. Except this time, the x-intercept is where y is 0. So I'm going to put my finger over the y. Now we have an equation that says 5x equals 12. Now let's solve that equation for x. Divide both sides by 5. So x equals 12 over 5. And we can find the decimal approximation of that. 2.4. Okay? So the x-intercept is 2.4. Now, in order to find the slope, we need to write this equation in slope-intercept form. Okay? Right now it's in standard form, and we want to put it in slope-intercept form. Which looks like this. Y equals the slope times x plus the y-intercept, which is b. So, let's do that on a separate sheet of paper here. I found the best way to do that. So here was the equation we started with, 5x minus 2y equals 12. Now, let's solve this equation for y. Solve for y. If we can successfully solve this equation for y, then we will have written it in slope-intercept form. Y equals a bunch of stuff. Okay? So the first step to solving this equation for y is to move the 5x. Okay? In order to move the 5x, we need to subtract it. Subtract 5x. So negative 2y equals, here, really what this says is 12 minus 5x, but due to the commutative property of addition, I can move this around. Okay, so that's really what it says. I just flipped it around to put the x first. Okay. Now the final step here is to simply divide both sides by negative 2. Now really what I'm doing is dividing the whole left side and the whole right side by negative 2. And I hope that you see that here the negative 2's cancel out, so I'm left with y. Here I have negative 5x divided by negative 2. So the negatives will cancel out, leaving me with 5 over 2 times x. 5 over 2 times x. And then here I have 12 divided by negative 2 is negative 6. Okay? So this is now written in slope-intercept form. Here's the slope, and here again is the y-intercept. Notice that this value, negative 6, is exactly what we found using the other method. So negative 6 is indeed the y-intercept. The slope is 5 over 2, which is the same thing as 2.5 if you do it in your calculator. Okay, so either one of those is acceptable. Alright, we are cruising along here. Now let's look at the very last problem. This one has a lot of reading involved. Santa Claus hands out candy canes to every child who walks through the door at the mall. The number of candy canes in Santa's bag, y, can be represented by the equation y equals negative 3x plus 84, where x is the number of children who have walked through the door. Answer the questions below. Choose from the lettered answer choices. There could be more than one correct choice. Okay? So we are asked, what does the slope of y equals negative 3x plus 4 represent? Okay? What does the slope of that represent? Well, the slope is negative 3. Now we have to ask ourselves, what does that negative 3 represent? Well, the slope, again, is the same thing as rate of change. Okay? The rate of change in y with respect to x. Okay? So the slope tells us how much does y change by when x changes. So in other words, how much does the number of candy canes in Santa's bag change when x changes? Okay? So when the number of children who walk through the door increases, how much does the number of candy canes in Santa's bag change by? Well, negative 3. Okay? So each time x increases by 1, when x goes up by 1, y goes down by 3. That's what the slope is saying. Now, which of these answer choices correctly explains what is happening here? When a child walks through the door, the number of candy canes in Santa's bag goes down by 3. Well, let's see here. Price of each candy cane, the number of candy canes that Santa gives to each child. Well, yeah, this one right here, B. The number of candy canes that Santa gives to each child. When a child walks through the door, the number of candy canes in Santa Claus's bag goes down by 3. That means that Santa is giving 3 candy canes to each child. So B is the correct letter choice. Now, let's take a look at the second question. What does the y-intercept of y equals negative 3x plus 84 represent? Well, the y-intercept is 84. Okay, the y-intercept is 84. Now, what does that mean? Well, when x is 0, so when x is 0, just like what we did up here, we found the y-intercept by saying when x is 0, y is 84. So when no children have walked through the door, the number of candy canes in Santa's bag is 84. Now what does that mean? Well, that is the number of candy canes that Santa had to begin with, right? So I'm just going to mark this out. So when no children have walked through the door, Santa has 84 candy canes. Letter choice C. Now we're not quite done yet. If you look through all of these answer choices, there's also another letter choice that could explain what the y-intercept represents. Look down at answer choice E, the maximum number of candy canes that Santa can give out, right? If Santa starts with 84 candy canes, that's as many candy canes as he can give out, okay? So letter choice E also could describe what the y-intercept of this equation represents. Now, let's talk about the x-intercept. The x-intercept is where y is 0, okay? So where y is 0. Now, when y is 0, that means that Santa no longer has any candy canes in his bag, okay? So Santa has no candy canes left in his bag. so y is 0. Now the x-intercept of this equation is the number that we can plug in for x to make this equation true. So in order to find that number, let's solve it. So we're going to subtract 84 from both sides. So negative 84 is equal to negative 3x. And now here we're going to divide both sides by negative 3. So negative 84 divided by negative 3 is 28. X is 28. Now what in the world does this mean? X is 28. Well, remember that X represents the number of children who have walked through the door. And if there's no candy canes left over, that means that 28 is the maximum number of children to whom Santa can give candy canes. Okay? So that goes right there, letter choice F. Okay? So 28 is the x-intercept, 84 was the y-intercept, and negative 3 was the slope. Okay? So this problem was meant to show you that the slope, y-intercept, and x-intercept all have real-world meanings, okay, in a particularly seasonal problem, seasonal situation. Okay? So I realize that that's a lot packed into this first page here, but I did a lot more work than you needed to in order to answer these